combining symbols together into a larger one. Okay? And innovation number 7 actually comes at the network layer. Facilitate the communications of these over a lossy communication layer. So how is the performance comparison? Okay, this is on the Foreman sequence, 30 frames per second. This is signal to noise ratio. The higher you are, the better. And this is the bit rate. Okay, MPEG-4 is in purple, H.264 is in blue. And as you can see, if you draw the line of equal performance, meaning that the same reconstruction quality, the bit rate of this guy is what? It's around, this is in kilobits per second, so this is about, I don't know, 40 something, 42 something, right? And the bit rate, this guy is 190. Okay, so that's more than 4 to 1. 4 times. Right, 4 times. In this case, for this particular setup only. And this is at a very low bit rate. Okay, so low bit rate means 264 will have a lot more power because it do all these exhaustive search. Okay, when you start moving to high bit rate, the performance difference is not as drastic anymore. Okay, but still, this is a major improvement, right? And the quality for the, if you take a look at the 2 frames, 39 kilobits per second here, look almost as good as 203 over there. What about other standards? Okay, so these are, this is 264, this is MPEG-4, this is 263, this is MPEG-2. Okay, and as you can see, MPEG-4 is roughly 263. MPEG-4 is roughly 263. Okay, they have so many things in common. Okay, so that's why they are so close together. Okay, and then MPEG-2 is what you see on your DVDs. Okay, now let's draw an equal line of performance. Okay, if you draw the line right at 34, okay, this gives you 50 kilobits per second roughly, and this gives you roughly about 100. So twice the bit rate. Okay, in this particular case. What it means is that for the same DVD, you can have 2 movies now instead of 1. Same disc. Okay. And I blow it up, so that's why it looks bad. But should I blow it up? Okay. Anyway, I want to show you this. We draw lines. We draw lines to show you the way that H.264 actually partition the blocks. Okay? And in the beginning, every block gets labeled as I. I means intra. Okay? That means there's no motion estimations. Okay? You just encode the block. I4 means the block is actually got split into 4 smaller blocks for encoding. I16 means they get encoded as a large one. So as you can see, all these things are so white, it doesn't contain any information, so they got encoded together. But this guy is complicated, so it got split into 4 by 4, okay? And then you have more similar things inside. Now, let's step through this thing one, okay? So here, all the motion vectors will be in blue, and the partitioning of the blocks become like this. And as if you notice, Pascal has the bus moving. The bus moving against the background, okay? So you should expect motion down here only, but not here, okay? The building is not moving. There's a small little flags here that's moved, but okay. Most of the backgrounds stay the same. So as I step through, you will see that all the motion vectors follow the bus. Look at the motion vectors. Yes. The one in blue. It follows the bus. See that? It follows the bus. Now, and the partition is also a lot more busy down here. Okay? Because in order to capture the bus, you actually have to partition the blocks a whole lot more than things up here. Okay? And then when you start going here, oh, is become crazy, right? Because you have the dome moving, things are flying all over the place, okay? So motion vectors are all over the place. This frame is very costly to encode. It costs a lot of bits. Okay? Yeah, and it turns out that we're not, even with the splitting scheme, we're not doing motion estimation very well. Okay, there's a whole lot of errors here. But at least all the motion vectors seem to be pointing uniformly in a direction, which indicates that there's a lot of consistency in the motion here. Okay, so the dome look like that. There's the CP stand for copy. So for whatever reason, those blocks matches very well with one of the guys in the previous frame. So I get copy over only. So some of the block here, for example, I4 indicates that they do motion estimation here, cannot find anything interesting. So okay, intra-coded this guy. Okay, that's the entire idea. And as you can see, the codec is so adaptive. It's searching all over the place for the best mode, okay, and choose it, then send to the decoder. Okay, let's see anything else that's interesting here. Maybe let me show you some. This look like the Empire State Building in New York City. Okay, so let's see. This is okay. Let me just play it. Okay, so this is a helicopter flying around at night, capturing New York City's skyline. Okay. It seems pretty dark up here, but on my computer it's actually nice. You can see a lot of details. You can see cars, you can see people. Okay, this is, so there are a lot of, looks like camera motions here. What happens? Okay. Yeah, this is like, looks like fair of some kind with rotating wheels for little kids to. So now let me show you something interesting. Okay, the video 1280 times 720. That's the mid-end HD high definition resolution. It tells you how many frames you have, the aspect ratio, the file size, you know, a whole lot of other information. Okay. Now, I can do, if I do this, it will show me all the motion vectors, okay? So let's go back and watch the sequence again with all the motion vectors being shown in red. So these are the motion vectors, and as you can see, the helicopter is moving this way, so most of the time you see horizontal motion vectors, okay? Oh yeah, there are actually a lot of small ones. Okay, here it should go crazy, right? There's a lot of motions. Some of these things are in red, so you don't see the motion, but there's actually a lot of motion. Okay, there's movement in and out so fast. Here, all the motion vectors are pointing together, so they seem to be connected, but they're actually a sequence of motion vectors here. Okay, this block point over here, this block point over there, so on and so forth. Mode, when you see red, is intra. That means no motion estimation whatsoever. And in the beginning, every guy is intra. Okay? In the beginning, every guy is intra. Then we have yellow and blue. I believe yellow is copy. That means you just call the blocks over. And blue is the one that actually has some motion compensations. Okay? So you see a heavy yellow flavor. There's a lot of copies, okay?